मैं बोल रही हूँ मैम तुम लोग करो ये देखो स्पेलिंग ऐसे लोगों को कीड़े पड़े काम करवाते अबे अच्छे लग एकदम नॉनसेंस मुझे बड़ा मेरे भाई के पास मेरी मैंने नहीं किया ये भी मैंने नहीं किया है Many to be asked, this is not me.
We start. Yes. Now we ascended. Okay, where did we stop in the last class? Right hand from last class में जो हमने डिस्कस किया था उसी को मैं डाउट है and that example you best example थोड़ा ये इसको फिगर right hand also imagine this is your conductor, okay? This is the conductor. Everybody silence. Now we are going to discuss the right hand thumb rule again. Can we discuss? So in this conductor, let us say the current is going upward. So how to apply right hand thumb rule? Align your thumb in the direction of current and then curl your finger around the conductor. So the finger should be around the conductor. It should not be like this. Okay. So then the magnetic field direction is along the curled fingers. So it will wrap around the current carrying wire. So if the current is going upward, it will be what kind of field? Anti-clockwise. If the current is going downward, then it will be clockwise field. Okay. And where are the field? Fields are in the plane perpendicular to the wire. Where is the field? Perpendicular in this plane. So if the current is coming towards you. Okay. So what will be the direction of field? Huh?
like this.
Clockwise.
Clockwise.
Right now. So like this clockwise.
Clockwise.
Anti-clockwise. When the current is coming towards you, what is the direction? Clockwise or anti-clockwise? How clockwise? How clockwise? Right hand thumb rule. यही तो है. Clockwise है. Current is coming towards you. हाँ. फिर कैसे पकड़ना है? तो अभी कहाँ हुआ तुम्हारा फिंगर कैसे जा रहा है? Anti-clockwise. Understood? तो it is दो चीज ध्यान रखना है. Magnetic field कहाँ बनेगा? Perpendicular plane में बनेगा. ठीक है? And it is clockwise or anti-clockwise as per the curled fingers of right hand. When the thumb is pointing in the direction of conventional current. So sometimes in the question they will give you the direction of electron. So will you align the thumb in the direction of electron or opposite to it? That's how they give you a tricky question. They will tell you that the electron is flowing in this direction. So then the current will be opposite to the direction of electron. That's how you solve the question. Okay. So now example 12.1. So what is given here? There is a horizontal power line. Okay, the current is going from east to west.
The magnetic field is perpendicular.
Let us say this is east west. Let's draw the direction.
So
Perpendicular to the plane. Perpendicular to the wire, current direction. Plane which is perpendicular to the wire. This way. Understood? This is our. This is the plane. Now the current is going from east to west. So east to west. So this is the direction of current. I. Okay. So how will it be? What is asked? What is the direction of magnetic field at the point directly below it and directly above it? So below it will be dot and above it will be cross. So if you see from this side, from east side, it will appear to you clockwise. From this side, it will be clockwise. So when the current is entering, okay, when the current is going away from you, it will be clockwise. But if the current is coming toward you, if you see it from this side, it will appear anti-clockwise. Is it understood? So cross means the field is entering. Dot means field is coming out. Repeat what? I just said how the right hand thumb rule is applied here. In this case, so hold your pen. Okay. What is the direction of current? East to west. Now apply right hand thumb rule. So thumb in the direction of current. So where is the finger going? So if it is like this, when you see from this side, यहाँ से देखोगे, ठीक है? Current is like this. Clockwise दिखेगा. Current is going away from you, right? When it is coming towards you, तब क्या होगा? Anti-clockwise. So this is how it is, and this is like cross. तो clockwise में क्या होगा? यहाँ से ऐसे जा रहा है ना? Like this. This is ये plane का ये back side, ये front side. What you are seeing is the back side. Back side में कैसा दिख रहा है? Clockwise. तो front side से कैसा दिखेगा? So you have to develop some perspective actually. It's this. This is like this, perpendicular. Okay. What is shown here is this. What is shown here is
From front perspective of that. Front perspective of that data.
say that again.
If you write the answer from
What is the question?
this question.
What is it? What is it? What is asked? What is the direction of the magnetic field at a point above the wire? मतलब यहाँ पे किधर है और यहाँ पे किधर है? तो यहाँ पे अंदर जा रहा है. That is shown as a cross. Cross means देखो ये डॉट और क्रॉस क्या है? साइन कन्वेंशन है एरो का. Let us say the arrow is going like this. So the tail of the arrow has the feather. So if the arrow is going away from you, you see the tail of the arrow. So tail of the arrow is represented by cross. That means the field line is going away from you. Cross. And point is the tip of the arrow. That means dot. When it is dot, the arrow is coming towards you. This is the sign convention. Dot means coming towards you. Cross means going away from you. So like if it is the arrow, right? If you are seeing the tail, that it is going away from you. Cross. If it is dot, coming towards you. Understood? So the answer to this question will be, what is the current direction? This is the direction of current. So here it will be cross and here it will be dot. Means above the wire, field is entering into the plane of the page. तुम्हारा जो notebook है, where are you drawing this? You are drawing this diagram in your notebook. So you can't show this plane here, right? Isn't it? So above the wire, the field is entering perpendicular to the plane of the paper. And below the wire, field is coming or emerging out perpendicular to the plane of the paper. Is that clear? This answer.
The answer is anti-clockwise.
तो anti-clockwise कहाँ से होगा? From here, front से देखोगे तो anti-clockwise होगा. When you look in west to east direction, then it will be anti-clockwise. And when you look from east to west direction, it will be clockwise. ठीक है? थोड़ा sense of direction perspective वो develop करना पड़ेगा. Is that clear? Is it clear to everybody? Okay. And you can take a rough page. उसके अंदर पेन ऐसे कर लो पेज के अंदर. तो the paper का जो plane है उसमें देखो किधर field बनता है. Apply right and thumb rule. So initially for few occasions you practice like that. Then it will be clear. Anybody has a rough page? Give me a rough page. कोई भी पुराना So what I'm trying to say is pen that movie. This is the scenario. This is the scenario, okay? Now current is going from east to west in this direction. Now if you apply right and thumb rule, तो कैसे अप्लाई करोगे? ऐसे, मतलब ऐसे यार. Okay? So this side it is clockwise. Clockwise. तो ये clockwise वाला drawing इधर से बनाओ, देखोगे तो कैसा दिखेगा? Anti clockwise. बस इतना ही. ठीक है? तो field or where is the field form? Magnetic field in the plane perpendicular to the wire. इस plane में बन रहा है magnetic field. Concentric circles. Near the wire, it is stronger. So the concentric circles will be crowded. As you go away, the concentric circle will be spread out. That indicates weaker field. Okay? So थोड़ा ऐसा करो थोड़ा graph. use करके. So next topic is keep that page. We will need it. Next is magnetic field. अपने पास में रख. Due to current carrying loop or coil. Now we are going to discuss magnetic field due to current carrying loop. पहले क्या लिया था? Current carrying straight wire. Now we'll bend that wire in the form of a loop, circle. तो अब क्या होगा? देखो. So easy way to understand is first take a plane. Okay. So take a cardboard like tabletop and drill 2 holes in it. Then pass the wire through it. So the dotted portion is
Portion below
the table. Okay. Now pass current into it. Let us say we have connected the cell such that current is entering from here and leaving from this side. Okay. So current is entering from this side and leaving from this side. So now in the plane, how the magnetic field will be formed? Concentric circle. So how is the current flowing? Clockwise, right? Clockwise. So what will be the magnetic field formed here? Like this. So magnetic field will be anti-clockwise. Out here it will be anti-clockwise, right? यहाँ पे क्या होगा? Now the current is entering. So here, when you apply the right hand thumb rule, you made anti-clockwise concentric circle. अब यहाँ पे क्या होगा? Clockwise. तो यहाँ पे कैसे बनेगा? Clockwise. ठीक है? तो likewise मिडल में क्या हो जाएगा? एकदम सीधे जाएगा. मिडल में क्या होगा? सीधा. Because circle will become so big that it will appear almost like a straight line. Okay? So likewise you'll have fields like this. So when the current is clockwise, you are seeing the field entering into the loop. ये कौन सा plane है? Perpendicular plane. And the field is everywhere. You can take the plane everywhere. Everywhere the field is entering into the loop. Okay. So this is when you see from this side of the table, field is entering the loop. But when you see from this side, field is coming out. Correct? यहाँ से जब देख रहे हो, तो field is entering inside. और जब यहाँ से देख रहे हो, field is coming out. समझ में आया कि नहीं? वो लोग वो पेपर दे. क्या? Yeah. Usually.
मैंने अलग ही डाल दी
Imagine this is your wire. Okay. So now we have turned it like a loop. Okay. Now how the current is going? Current is entering from this side. It is making a clockwise. So the current direction is clockwise for you. Now on this side, if we take, let's say there is this horizontal plane. तो यहाँ पे अगर right hand thumb rule लगाओगे, so current is going up. Where are the field going? Into the loop. Everywhere. Everywhere the field is going into the loop. For you, it is going into the loop. But what about me? It's coming towards me. यहाँ से घुस रहा है और इस तरफ से बाहर आ रहा है. Okay? So for you, the field is entering. For me, the field is coming out. So if you compare it with the magnet, South pole में क्या होता है? Field lines enter the South pole and they come out of North pole. So a current carrying loop acts like a electromagnet. With one side acting as South pole, the other side acting as North. So it's a very thin magnet. This is the smallest electromagnet possible. Just one coil. So now what do? I can have multiple turns. Okay. This is called solenoid. What is it called? Solenoid. So now if I have multiple turns, when I have multiple turns, so my magnetic field will, it is a vector field. Each turn is producing its own magnetic field. That will get added. So the more number of turns will produce a stronger electromagnet. Is that understood? Yeah. So every time we have more number of coils, the magnetic strength will increase. It will increase by n times. Let's say n is the number of turns, the magnetic field will increase. Is that clear? That's what is electromagnet. Okay. So सबसे पहले we saw. So if I turn the table by 90 degree like this, if I turn the table by 90 degree, वो diagram तुम्हारे book में दिखा है. The diagram shown in your book is the cross section of the coil. Okay. So to understand it from this, it becomes little difficult. So this is better. And then when you turn the table like this, the coil will become vertical. So what is shown here is okay. What is shown in the book is this. The same thing if I turn by 90 degree. So अब क्या होगा? This is still a clockwise current. So how do you? So the field will enter from here and it will come out from here. Is the diagram given in the book understood now?
Yes.
So it is the same diagram when the table is turned like this by 90 degrees. So even for the circular coil, what rule you are applying? You are applying right hand thumb rule only. Keep the thumb in the direction of current, and you will get the direction of magnetic field. समझ आया सबको? So what is the conclusion? Conclusion is this side will act as a clockwise current. When the current is clockwise, clockwise current means it will develop south pole. Clockwise current develops south pole, and the north pole will be anti-clockwise current. This is the rule. So this diagram will help you remember which pole is getting developed in a circular loop. So when you see it from this side, the current appears anti-clockwise to you. When you see it from this side, the current appears clockwise to you. Okay, so this is what is nothing but magnet also. Magnet में one side is north, यहाँ से field बाहर आता है. The other side is south. So this is the thinnest or smallest electromagnet possible. What is the smallest electromagnet possible? A single circular current carrying coil, single coil. Coil is multiple loops. So this is a loop. A coil will have multiple turns. Okay, so then the coil is called solenoid. That is the next point. Okay, so let's discuss now magnetic field due to a. So is this understood? Magnetic field due to a current carrying loop.
So how North Pole and South Pole will be there?
This is a loop. How?
North Pole and South Pole will be there.
Yeah, this is. I told you now. What is North Pole and what is South Pole?
Clockwise is South.
South Pole. Clockwise is South Pole. When you look at the loop, when you see it as a clockwise, that end is South Pole. When you flip it, that becomes North Pole. Because now the current will appear anti-clockwise. Current direction change नहीं होगा क्योंकि तुमने जो supply connect किया है वो थोड़ी ना change होगा. You're only seeing your weaving angle. That's all.
So it can be both North Pole and South Pole.
कैसे हो सकता है भाई?
The clockwise will be South Pole. So we are seeing it from different angles.
Different angles नहीं मतलब 180 degree opposite. या तो तुम इस तरफ से देखोगे या उस तरफ से देखोगे. फ्रंट या बैक ऐसा ऐसा है. डिफरेंट एंगल से मतलब 180 डिग्री में तो उतना ही रहने वाला है. तो हम यहाँ से ये क्या हो गया, ये फ्रंट हो गया. ये साइड है फ्रंट. ये तुम एक्सपेरिमेंट कर रहे हो, ये तुम्हारा साइड, ये हो गया फ्रंट और ये क्या हो गया बैक. ऑपोजिट साइड से जब देखोगे तो करंट का डायरेक्शन उल्टा दिखेगा. अंडरस्टूड? तुम लोगों को समझ में आया क्या? किसी को कोई डाउट है यहाँ पे? तो ये लिख लो, ये सबसे इंपॉर्टेंट यही है. सारे क्वेश्चंस तुम्हारे इससे सॉल्व होंगे. ठीक है, अभी तक दो रूल समझे आपने, राइट हैंड थंब रूल और एक ये क्लॉकवाइज एंड एंटी क्लॉकवाइज रूल. ठीक है, स्ट्रेट वायर में करंट एक ही डायरेक्शन में चलेगा, लेकिन यहाँ पे क्या हो रहा है, या तो क्लॉकवाइज चलेगा लूप में, या तो क्लॉकवाइज चलेगा या फिर एंटी क्लॉकवाइज। तो उसमें फील्ड का डायरेक्शन कैसे देते हैं मैंने बताया। ठीक है, अगर मैं इसमें करंट का डायरेक्शन उल्टा कर दूं तो फील्ड क्या हो जाएगा, उल्टा हो जाएगा। मैग्नेट में ऐसा पॉसिबल है, बाहर मैग्नेट में क्या हम उसके पोल्स को रिवर्स कर सकते हैं, नहीं कर सकते, लेकिन इलेक्ट्रोमैग्नेट में वो फ्लेक्सिबिलिटी है। क्या हम बाहर मैग्नेट का मैग्नेटिक फील्ड स्ट्रेंथ इंक्रीज या डिक्रीज कर सकते हैं, नहीं कर सकते। यहाँ पे करंट का मैग्नीट्यूड बढ़ाया तो मैग्नेटिक फील्ड का स्ट्रेंथ बढ़ जाएगा। तो दिस इज अ फ्लेक्सिबल मैग्नेट, इलेक्ट्रोमैग्नेट इज अ फ्लेक्सिबल मैग्नेट, वी कैन इंक्रीज और डिक्रीज द फील्ड ऑन डिमांड, जो परमानेंट मैग्नेट में पॉसिबल नहीं। समझ आए? सो इट हैज मेनी एप्लीकेशंस। So let us discuss magnetic field due to solenoid. Magnetic field due to solenoid. अब solenoid क्या होता है देखो, मान लो ये हमारा कोई हॉलो पाइप है, ठीक है, हॉलो इंसुलेटिंग पाइप। अब उसके ऊपर हम क्या कर रहे हैं, वायर रैप कर रहे हैं। क्या कर रहे हैं, वायर रैप कर रहे हैं। तो अभी वायर रैप करते हैं इसको। ठीक है, now we can let us say the current is entering from this end and it is leaving from this end. We can apply some cell or any power supply. So this is how the current is. So this is how the current direction will be. So when you see from this side, what is the direction of the current, clockwise or anti-clockwise? From the left hand, it is clockwise. That means field will go inside. है ना? मतलब कैसा field बनेगा? ऐसा बनेगा। ठीक है? और यहाँ से ये तुम्हारा बेसिक रूल है। क्लॉकवाइज से फील्ड अंदर जाएगा और जहां से इधर से देखोगे तो एंटी क्लॉकवाइज है, एंटी क्लॉकवाइज से फील्ड बाहर आएगा, मतलब यहाँ पे तुम्हारा साउथ पोल बनेगा। दिस एंड विल बी साउथ पोल and this end will become north pole. This is south and this is north. Okay, so this is the electromagnet. So these diagrams are asked to draw. समझ आ गया? So what is the solenoid? Not multiple. Solenoid is a coil. So the wire wrapped in a cylindrical fashion. Okay. So wire wrapped in a solenoid. Oh. So what is a solenoid? The wire wrapped in the form of a cylinder. रबर का नहीं हो सकती, ये वैक्स कोटिंग होती है, they are insulated. So these wires, you are seeing space. Actually, there is no space. They are very close to each other. Physically, they are in contact with each other, but they are actually insulated from each other. मतलब, there is no electrical contact between the turns. Okay? Here, the turns are insulated. ठीक है, मतलब ये दोनों कॉइल एकदम क्लोज आपस में टच हो रहे हैं तो भी उनके अंदर कोई इलेक्ट्रिकल कॉन्टैक्ट नहीं, समझ आए? तो ईच टर्न इज अ सेपरेट लूप, इलेक्ट्रिकली इट इज अ सेपरेट लूप. Each loop is producing its own magnetic field, and all of them are getting added. So more the number of turns, more stronger the field it will produce. Okay. Now if you look at it, the magnetic field of the solenoid is exactly like a bar magnet. Okay. The magnetic field you see. A solenoid is like a bar magnet. Okay. ठीक है, but solenoid is a electromagnet. What is a solenoid? It is a electromagnet. मतलब जैसे करंट ऑफ करेंगे वो मैग्नेट रहेगा क्या? नहीं, ठीक है. So what is this? What is this? ये जो we have got only for support, मतलब वायर रैप कैसे करो? It could be a plastic pipe or it could be a cardboard cylinder just to wrap the wire. You can remove it after. Okay, once you have wrapped the wire, you can remove it. So then, what is inside? So this is called port. This is called port. Okay. So when there is nothing inside, the core is air. What is the core? अभी जैसे हमने एक बार इसको सपोर्ट लेके रैप कर लिया, ठीक है? There you go. The purpose of this pipe is only to wrap the wire. अब इसको wrap करने के बाद मैंने निकाल दिया. What remains inside? Air. So right now the core is air. What is the core? Air. ठीक है. If I insert soft iron core, what do I insert? Soft iron core. Then the magnetic strength is even more enhanced. Understood?
Sir, but top direct code is not touching the wire.
No, the wire is touching, but there is no electrical contact because the wire is coated.
Then how?
Due to this, there is external supply. External supply तो है ना इसको. ये तो दिया है ना बाहर से.
लेकिन से वो टच नहीं करेगा.
टच नहीं करेगा, लेकिन वो अगर इसमें हम मेटलिक कोर डाल देंगे ना, तो ये मैग्नेटाइज हो जाएगा कोर, और वो अपना खुद का मैग्नेट इसमें ऐड कर देगा, मैग्नेटिक फील्ड. वो मैग्नेटाइज होके खुद की फील्ड बना लेगा, and that will get added to the electric field due to the current. समझे? So different core have different magnetic susceptibility. It is called. I have studied the topic. But तुम्हारे बुक में कभी कभी आ जाता है how to increase the strength of the magnetic field of the electromagnet. There are three ways. One is increase the magnitude of the current. Second is increase the number of turns. 3 की वजह 30 कम. These are two ways. Third is in inserting the soft iron core. उससे भी बढ़ा. Understood? So what are the ways to increase the magnetic strength? So difference between solenoid and permanent bar magnet. So although the magnetic field produced is like a bar magnet, but it has some differences. What is the difference? The magnetic field strength can be okay. Yes. Can be increased by yes, increasing the magnitude of current. What else? Increasing the number of turns. Inverting of these are some ways by which you can increase the. So this is the first part. What is the second difference? It is a temporary magnet. Its polarities can be interchanged. By changing the direction of current. The polarities of the electromagnet can be changed by changing the direction of current. Third, it is a temporary magnet. It is a temporary magnet. तो भाई ये परमानेंट मैग्नेट बनाते कैसे हैं बार मैग्नेट? ये सोलेनॉइड के अंदर रख देते उसको बहुत देर में, तो परमानेंटली मैग्नेटाइज हो जाता है। समझा? जो मैग्नेटिक सब्सटेंस है उसको हम क्या करते हैं, अंदर रख देंगे सोलेनॉइड के, एज अ कोर। यस एग्जैक्टली, तो वो क्या हो जाएगा, परमानेंटली मैग्नेटाइज हो जाएगा। लेकिन जो सॉफ्ट आयरन है, अब अलग अलग मटेरियल हो जाएगा। स्टील का है, स्टील परमानेंटली मैग्नेटाइज हो जाता है, लेकिन सॉफ्ट आयरन परमानेंटली मैग्नेटाइज नहीं होगा। इसलिए सॉफ्ट आयरन, इलेक्ट्रोमैग्नेट में इसीलिए क्या यूज करते हैं, सॉफ्ट आयरन, क्योंकि हमने वो देखा होगा जो स्क्रैप आयरन है को लिफ्ट करने के लिए क्या यूज करते हैं, क्रेन में एक बहुत बड़ा इलेक्ट्रोमैग्नेट लेके जाते हैं स्क्रैप के ऊपर, फिर इलेक्ट्रोमैग्नेट एक्टिवेट करेंगे, वो पिक करेगा उससे, दूसरी जगह लेके जाके करंट ऑफ करेंगे, तो करंट ऑफ करेंगे तो वो छोड़ना चाहिए ना, मतलब मैग्नेटिक प्रॉपर्टी ऑफ हो जाती है सॉफ्ट आयरन में, ठीक है, तो वैसा नहीं तो चिपके रह जाएगा उसके अंदर। So do you have any questions on solenoid? Hmm? No? हाँ? Naturally भी बनता है, yes. लेकिन natural magnet का problem ये है, it is not having proper magnetic strength. It is weak for any practical purpose. उसका shape भी वैसा नहीं है जैसा हमको चाहिए। Natural magnet जैसा है वैसा है ना? ये हम forging करके जैसा चाहिए वैसा बना सकते हैं। We can have the core of appropriate shape. ठीक है? So we can actually manufacture magnets as per our need. और ये इलेक्ट्रोमैग्नेट ऐसा है उसको हम किसी भी डिजाइन में कर सकते हैं, तो लोग चाहिए, ठीक है? So this is what it is. Okay. So you can just read through this table, right? There are some more substances given which are suitable for making permanent magnets. So for permanent magnet, you use steel, chromium steel, cobalt steel, tungsten steel, alnico, nickel mag, etc. Iron या steel. Iron का बहुत variety है. There are different types of cores of iron. Soft iron is one type of core. ठीक है? Magnetic substance होना चाहिए. Steel is also made of iron, but that is suitable for making permanent. Soft iron is suitable for making electromagnet. Because
polarities can be inverted.
और साउथ हो जाएगा, साउथ नॉर्थ हो जाएगा। करंट का डायरेक्शन चेंज करेगा तो क्लॉकवाइज एंटी क्लॉकवाइज, तो एंटी क्लॉकवाइज क्लॉकवाइज, ठीक है? Yes. Next is force on current carrying conductor in a magnetic field. So this is magic. इसी पे पूरी दुनिया चल रही है आज की डेट में। क्या बोल रहा है ये? Whenever you keep a current carrying conductor in a magnetic field, it experiences a force. Obviously, अभी एक एक्सटर्नल मैग्नेटिक फील्ड है, सुनो ध्यान से, एक एक्सटर्नल मैग्नेटिक फील्ड है, उसके अंदर तुम क्या कर रहे हो, करंट कैरिंग कंडक्टर रख रहे हो, तो करंट कैरिंग कंडक्टर अपना खुद का भी तो मैग्नेटिक फील्ड बना रहा है, मतलब मैग्नेट के बीच में तुमने मैग्नेट रख दिया, तो two magnets will either attract or repel. तो force तो लगेगा. इसी से मोटर चलता है. मोटर में जब तुमने स्विच ऑन किया तो क्या होता है? मैग्नेट के बीच में मैग्नेट आप, and then the current carrying coil experiences force, and the design is such that it produces rotational motion. वही तुम्हारा इलेक्ट्रिक मोटर है.
फिर तो फिर हम उसका परमानेंट मैग्नेट यूज करेंगे तो
नहीं, वो उसका दोनों ही इलेक्ट्रोमैग्नेट, परमानेंट मैग्नेट नहीं हो.
तो फिर परमानेंट मैग्नेट यूज करेंगे तो कम फ्यूल लगेगी.
हाँ,
परमानेंट मैग्नेट यूज करेंगे तो कम फ्यूल लगेगी.
हाँ कम लगेगा, लेकिन जब परमानेंट मैग्नेट बनाया था उस टाइम पे फ्यूल लगा दिया था तो उसका पैसा भरोगे. खरीदना तो पड़ेगा कि नहीं मैग्नेटिक, तो रेकरिंग कॉस्ट नहीं होगी. ठीक है. तो ये जो मोटर चल रहा है ये है क्या बेसिकली? इलेक्ट्रोमैग्नेट. ठीक है. तो अभी नेक्स्ट हमको वही सीखना है कि करंट कैरिंग कंडक्टर पे फोर्स कौन से डायरेक्शन पे लगता है. यहाँ पे आया तुम्हारा फ्लेमिंग लेफ्ट हैंड रूल. Left hand rule. Fleming's left hand rule. This. What is this? This is the direction of magnetic field. This is the direction of current. And this is the direction in which wire will experience force. ठीक है? So देख लो क्या है वो. Force acting on a current carrying conductor is given by Fleming's left hand rule. अभी ये क्या है? ये देखो जो लेफ्ट हैंड है हो गया कम. तो जो फर्स्ट फिंगर है इट गिव्स द डायरेक्शन ऑफ मैग्नेटिक फील्ड. मिडिल फिंगर गिव्स द डायरेक्शन ऑफ करंट. थंब गिव्स द डायरेक्शन ऑफ फोर्स. ओके. ये है तुम्हारा फ्लेमिंग्स लेफ्ट हैंड. और स्पेलिंग आ गई. ठीक है. So the index finger indicates the direction of magnetic field. Middle finger indicates the direction of current, and thumb the direction of force. So answer B. B is your magnetic field direction. Magnetic field.
Yes.
So ये हो गया तुम्हारा Fleming's left hand rule. कब when the thumb, index finger and middle finger are stretched mutually perpendicular to each other. Okay. So what is the Fleming's left hand rule? So FLHR. Then right finger. Stretch. This is what it is. What is Fleming's left hand rule? When thumb, index finger and middle finger are stretched perpendicular to each other. When thumb of left hand sorry for very small writing.